All right, sorry guys. Ellipse part 3 of the homework. I'm trying to do this every time I can get in the day. So I am now starting on page 364, and we're starting with number 16. I'm going to finish this out, 16 through 19. We're doing all of this right now. All right, so the third part, 16. So 16 is right here. So it's x minus 4. I'm looking right at Springboard right now. X minus 4 squared over 4 plus y plus 2 squared over 9 equals 1. Okay, this is number 16, and they want us to sketch the graph, label the center, the foci, and the endpoints of the major. They kind of just say label, but I think that actually means like say what they are. Or you can actually label right on the picture if you want. So let's just do that this time. All right, let's get our graph ready. All right, so we have x-axis and y-axis. So let's start with our center. Our center is the opposite of this number. So it's 4, negative 2. Okay, it's 4, negative 2, so we're going to go 4 to the right and down 2. And when you label it right on a picture, you can actually just label it right on the picture like this and put a little C. So I'm labeling it. So you don't have to label it to the left if you want to label it right on the picture. It says when it says label, either label it right on the picture or label it off to the side. All right, your major vertices. Look at the bigger number. The bigger number this time is under y. So this one's going to look more like this instead of, so it's going to be more vertically elongated because the bigger number is under y. So what's the square root of 9? Square root of 9 is 3. Okay, so that means that a squared is 9, and a is plus or minus 3. So from the center, we're going to count 3 to the right, and that will be 7, negative 2. And go back to the center and go 3 to the left, and that'll be 1, negative 2. Sometimes it's easier to say what they are right as you're doing them. Now you go back to the problem and you find b squared. B squared is 4, so b is plus or minus 2. And that's under, oh, I just did this wrong. This was supposed to be up and down. I have to get my white out. White out. Sorry, hopefully you didn't do what I just did. Oops, I just messed up my thing. I was supposed to go up and down, people. Why didn't you guys tell me that? Because I'm on a video and you can't tell me that. Boo-boo on my part. So that, go back to a squared. That was supposed to be 3 up. So that should have been here. And that is 4, 1. And go back to your center and then go 3 down. And that is 4, negative 5. That's where you were supposed to go in those first ones. So the b squared, back to b squared. B squared is 2, and that's under x, so we're supposed to go right and left 2. So here, which is going to be 2, negative 2. And then here, 1, 2, which is going to be 6, negative 2. So you got your 4 main points here. So draw your best vertically elongated ellipse. So there it is. And the only thing else that you have to label is your foci points. And here's your foci formula. So c squared equals your bigger one minus your smaller one, and that is 5. So that is plus or minus square root of 5, which is about 2.2. So that's up 2.2 and down 2.2. And that's kind of hard to label. So maybe you just like do a little thing like this. And that point is 4. And then write your center, negative 2 plus radical 5, like that. That's one way to write it. And then this one is 4, negative 2 minus radical 5. That's one way you can write those. Or you can use the decimals. It's up to you. The decimals are harder, believe me. Okay, 17 is completing the square. So I'm doing this on the other side because I need blank paper for this. 17, we have 4x squared. Uh-oh. These do not seem to be nice numbers, so we might get some ugly numbers on this one, but that's okay. Not everything's going to be a perfect square. So this is, the reason I know this is an ellipse is because you have a plus between your 2 squares, and the 4 and the 3 are different. That's how you know something is an ellipse. So let's go ahead and group our x's. The x's don't seem to be that bad. It's those y's I'm a little bit nervous about. And then your y's, 3y squared minus 6y. And we're going to add 5 to the other side. Okay? So we need to take a GCF. You're not allowed to complete the square if there's a number bigger than 1, so let's factor out a 4. And let's factor out a 3. And let's leave space for 2 new numbers. So let's go back and complete the square in terms of x. All right, what is? So we're not using any of these, by the way. What's half of 2? 1. What's 1 squared? 1. What are we adding to the other side? Not 1, but 4. Because 4 times 1 is 4. If you redistribute it, but don't redistribute, you're just kind of mentally doing that. Now what's half of negative 2? Negative 1. Negative 1 squared is positive 1. And you're going to be adding 3 to the other side. So if you complete the square, this is 12 over here. This will be x plus half of 2. Make sure the square is in there. And then this is y minus half of 2. And I already added up to the 12. So to put this in standard form, we need to divide everything by 12. And 4 twelfths is really 1/3. So you can write 1 and a 3 right there. What's 3 twelfths? 1/4. So that one's not bad, but this 3 one's not too great. And this one wanted you to do the same thing, sketch the graph. So the center looks to be negative 1, 1. The center is negative 1, 1. Your major vertex is going to have something to do with the 4. So a squared equals 4. A equals plus or minus 2. And that's going up or down. So I'll do this right this time. So that point is negative 1, 3. And then go down 2. And that is negative 1, negative 1. Now your major vertices are negative 1, 3 and negative 1, negative 1. Your minor vertices have to do with b squared. So b is plus or minus square root of 3, which is about 1.7. So you're going to go about 1.7 to the right and 1.7 to the left. I'm going to draw my ellipse. Now, I don't usually like to use decimals too much, so what we're going to do is look at this. For our b's, you'll notice on the center is negative 1, 1, that they're going through the positive 1, the y equals 1 is for the minor axis. So in your minor vertices, they're both going to have a 1 for the y coordinate. Okay, it's the x's that change. Since the x coordinate of the center is negative 1, right? Negative 1 plus square root of 3, negative 1 minus square root of 3. That's, to me, the easiest way to write that for your minors. I know, radicals are the most pleasant thing in the world. And your last thing is your foci points. So it is 4 minus 3. This one's not going to be too bad. That's 1. So C is plus or minus 1. So go back to your center, and your foci, your vertices, your major vertices are up and down. So go up 1, down 1. So it looks like your foci points were negative 1, 0, and negative 1, 2. Those were your foci points, foci 1 and foci 2. Okay? And, oh my gosh, you guys are just going to kill me for this homework, aren't you? I'm so sorry. So sorry. You know what? Maybe I'll just do 18 on this other side. I want to do 18 on this other half of this graph paper. Or should I do it on, yeah, I'm out of room there. 18. I actually need regular paper. I'm trying to find a blank piece of paper that I haven't used. Oh, I see one. All right, 18. 9x squared plus 16y squared minus 18x plus 64y minus 71 equals 0. All right, let's do this. Group your x's. Group your Y's. Add 71 to the other side. Blank, blank. Let's factor out a 9. Let's factor out a 16. And 64 divided by 16 is 4. And let's complete the square. You guys with me? What's half of negative 2? Negative 1 squared? 1. What are we adding to the other side? 9. So we have 71 plus 9 so far. Now over here, what's half of 4? 2. What's 2 squared? 4. What are we adding to the other side? 16 times 4, which is 64. Let's complete the square. Write this as a binomial square. So you write one of the x's, and then that's going to be half of negative 2. Make sure the square is on the outside. What's half of 4? 2. And if you add all these up, this is 80 and that 144. So standard form of an ellipse, you have to divide by 144. If you punch this in your calculator, 9 144 says 1/16. Punch this into the calculator. 16 44ths is 1/9. So the 9 goes to the bottom. We don't need the 1, and that's a 1. Ready to graph. Center is 1, negative 2. Major vertices are going to be this way. They're going to be longer, going left and right here. So A is 4. A squared is, A is going to be 4, and we're going left and right. So go 1, 2, 3, 4. That is 5, negative 2, and go 1, 2, 3, 4. And that looks to be negative 3, negative 2. So I added 4 to 1, and I subtracted 4 from 1. That's major vertices. Minor vertices are going to have to do with a 3, because b squared is 9. So b is plus or minus 3, so we're going to go up 3 from the center, which that looks to be 1, 1. And we're going to go down 3 from the center, which needs to be 1, what? I subtracted 3 from that. That should be negative 5. Let's draw our best ellipse. I missed, see that point, how I missed that? I would take a point off my own. I need to like make sure that I hit that vertice. And your foci points are going to be 16 minus 9, which is 7, which is plus or minus square root of 7, which is about 2 point something. So it was estimated to be about right here. But I don't want estimating when you're telling me what it is, but I do want you to put them in there. So your foci points are, so what you need to notice is that they're all on this line, which is the y equals negative 2 line. So that's the part that's not changing. So you take the x-coordinate of your center, which is 1, and you write that, and then you put plus or minus square root of 7. So it's kind of your center, but you're just adding plus or minus radical 7 to the x. And that's how you write your focus points. Foci. All right, last one, 19. The Whispering Gallery in St. Paul's Cathedral in London has an elliptical ceiling. The sound made at one focus of the ellipse is reflected to the other focus, allowing people on opposite sides of the room to clearly hear each other's whispers. Suppose that a whispering gallery is to be constructed so that foci are 20 feet from the center. What does that mean right there? That the foci are 25 feet from the center. What that means is that C is 25. Okay, and they actually write this. This is foci 1 and foci 2. You see that in the problem? So this is our drawing right here. Okay, now, let's keep reading. The height of the room at its center is 13 feet. The height of the room at the center is 13 feet. So we need to go 13 the other way. Find an equation that models the elliptical curve of the ceiling and find the length of each room. Oops. So your room's not going to look like that. Your room's actually going to look like this. We're going to go beyond the focus points. So it looks like we know that the vertices, okay, the major vertices are going to be on the same line as the foci. So the majors are over here. So this 13 is not A. 13 is actually your B. The majors have to be on the same line as your foci. So this right here is your minor vertice. Okay, so what we know from this problem is that C is 25, that's center to foci, and that B is 13, that's center to the ceiling. So how do I find A? We use our foci formula. So 25 squared equals A squared minus 13 squared, which is I think 625, and I think this is 169. Add 169, was this right? I feel like I'm not doing something right. 169, 4, 9, and 7 equals A squared. Okay, so A squared is 794. B squared is 13 squared, which is 169. So you take that B and you square it. Those are always in your equation. It looks to me that the center is 0, 0 in this problem. So if you look at, it's longer this way, right? So we need type 1 on the front of your notes, which is this. I'm going to write down the formula. So as you're writing an equation, you need to write this down. So the center is 0, 0, so that's going to be x squared, y squared. The a squared needs to go under x because it was longer this way. So the a squared was 794. The b squared is 169. And there's your equation. Then it says find the length of the room. So what's the square root? Okay, so the length of the room, guys, is the same thing as your major axis, I believe, right? The length of the room should be the length of your major axis. So the length of your major axis is 2a. So since a squared is 794, I really need to know what a is. So we're going to take the square root of 794. And that equals 28.178. So a equals 28.178. And the length of the room is 2a because it's the whole thing across, okay? So this is the length of the room right here. The length of the room is from major axis to major axis. This is the length of the room. Not from foci to foci, but from major axis to major axis. So you're going to take the 28.178 and times it by 2. Okay, so I'm just going to, on my calculator, times this by 2. So it's about 56.35 feet. So I'd say it's about 56.4 feet long. That's how long it is. Okay, sorry about the lengthy homework. It'll only make you stronger. Love you all.